Okay, 8.5. Yesterday we introduced the concept of vectors. We checked, our first practice problem was determine if given vectors are equivalent. You are going to see the word equivalent, which is just this another word for congruent or equal. It's not as simple as just finding the length of it. You also have to find the slope of them to determine that they are equivalent. This picture here is showing you what equivalent means. If you need to add on this picture if you want to, but these vectors in the top, number one, are pointed in the same direction with the arrows going in the same direction, and number two, have the same length. So these are what's called equivalent. And then down here at the bottom are examples of vectors that would not be equivalent, whether they have different magnitudes, which is length, or different directions, which is slope, or they can have the same magnitude but different directions. Notice the arrows here are totally different directions, or they can have different magnitude but the same direction. So you were supposed to practice this with these two questions right here. I personally, they give you the coordinates. I came over here and listed them, so I wasn't reading it from the directions, and I wrote it in order as how they named the vector. This says BA, this says DC. Okay, so in order to show the vectors are equivalent, we've got to show that they have the same magnitude and the same direction. Magnitude comes from the distance formula. So for vector A and the BA in the distance formula, remember the order that you plug in here does not matter. As long as you've got your x's grouped together and your y's grouped together, doesn't matter how you subtract them in the parentheses. So I'm just going to subtract them by reading it. X, we've got 3 minus negative 2 squared plus 4 minus 2 squared. If you type that in your calculator, you get 29. Carry the square root and just leave it. You don't have to break it down. And then come over here and repeat with DC. So we've got negative 1 minus negative 6 squared plus negative 1 minus negative 3 squared. And if you type it in your calculator, you get 29 again. So far they have the same magnitude. Same magnitude tells me that they have the same length. So now I would need to continue in checking the slope. So I'm going to check the slope for BA right here. Slope formula matters. However you choose to subtract the y's has just set the tone on how you have to subtract the x's. So looking at my stacked points, which is also helpful because then your x's line up and your y's line up. It's really helpful to stack them. So I'm going to subtract the y's. I'm going to do the lower one minus the top one. So 2 minus 4 over negative 2 minus 3. So that's negative 2 over negative 5. What's a negative divided by a negative? Positive. So now I'm going to check DC. Y's first, so negative 3 minus negative 1, negative 6 minus negative 1. So that's negative 3 plus 1. You can type this in your calculator if you wanted to. Negative 6 plus 1, which again comes to positive 2/5. So because these checked out and then these checked out, we can say that vector BA is equivalent to vector DC because they have the same magnitude and the same direction. Then you're going to repeat this right here. Bless you. Notice they did change the letters here. Now it's AB instead of BA. So it is a totally different vector, even though it's the same letters. Okay, so if I check the distance formula, so take the x's, take the y's, plug it in, you get 20, square root 20. And then when I check AB, X's, and the Y's, you get 29. So if that happens, I would check your math again just to make sure, but immediately right here, this is a problem. They are not the exact same value, which tells me that vector DE is not equivalent to vector AB because they have a different magnitude. Another thing with the magnitude, in terms of checking it in your calculator, you really could type the entire thing, even with the square root. You're going to get a decimal, but you could leave it and then just type the entire second one and check the decimals if you don't like having to remember just to enter the radcan. But on paper, it looks nicer to confirm, if you put on paper that DE is this and AB is that, instead of having to write that decimal. But either way works. Do you have any questions on checking magnitude or direction? You just got to remember magnitude. Just think of like opening your arms, like what's the magnitude of the problem, meaning how long is it, so distance. And then direction is slope. Okay, if you look at this slide, this is showing you that we can take two vectors and we can add them together. If you look right here at this picture, top right, you have vector u in one direction, you have vector v in another direction, and then you have the pink vector, which is the sum of the two, to give you a visual. Okay. You will notice that when we do these problems, it always forms a parallelogram. Okay. Or there's going to be a right triangle when we get to the one where it says that it's perpendicular. But there's a parallelogram involved. Just a real quick refresher, a parallelogram is like a rectangle that has been pushed. Okay? So opposite sides are equal, opposite, you don't need the angles, I don't think. Yeah, I don't remember. Yeah, opposite angles are equal. And consecutive angles are supplementary. So that's stuff from geometry. When it comes up, I'll say, hey, remember this, and we'll write it down. Look down here at the bottom. So here's a complete vector sum picture visual. You will notice that vector u here is running along the horizontal. Vector v is it's slightly vertical. That is this picture, but they just filled in the reflected side, okay? Notice there's a symmetry about it. So if I say this vector is going this way and it's vector u, and then I say this vector is going that way, it's vector v, and then I absolve the vector by drawing the sum, I can finish the parallelogram by copying vector v over here and copying vector u up there. So that's where that picture comes from. It starts as a triangle, but then you finish it by filling in the parallelogram, by copying the vector to the opposite side, okay? Let's make some notes on here. Keep in mind, opposite sides of parallelograms are congruent, so I'm going to put tick marks to remind you that opposite sides are equal. So when they give you one vector, you know, in a problem like this, a vector sum problem, you actually have two sides of the parallelogram when they give you just one vector because their opposite sides are equal. I was going to write it right here, but it looks really crowded on my paper. So you could put it right here if you want. I'm going to come up here so you can see what I'm writing. Recall, this is from geometry. Opposite sides are congruent. We are talking about parallelograms, by the way. Opposite angles are congruent. And this is probably the one you may not remember, but when I say it, maybe it'll come back to you. Consecutive angles are supplementary. What does supplementary mean? They add to 180. So let's put in parentheses right here. Angle plus angle equals 180. You're going to see this in practice in just a minute. But go ahead and just write it right there. Those three concepts from geometry are going to come up in every one of these problems to help you answer it, okay? That's not something new. That's stuff you just not done in 2 years. But a lot of it makes, or two of them, in my opinion, make sense because when I look at the picture, I see symmetry. So, like, I know that this angle here looks exactly like that angle there. You know what I mean? Same thing here. I know that that angle appears to be the exact same as that angle. So, in my mind, it's not necessarily properties I have to memorize because when I look at the picture, I kind of deduce that. Now, the consecutive one, you're going to have to memorize. But I have a visual mind. I see in my mind, I imagine this angle right here. You with me? I imagine breaking it off. Imagine if I could do it on the actual board. I imagine it right here, it stays the same, and I slide it over and I lay it right there, almost like a tile. Do you see what I just did? Can you visualize that? So in my mind, I see this visual of that angle sliding right here, and then I know that's 180 degrees. So that's how I remember the same side. Consecutive means side by side, meaning if you traced that side, it's talking about that angle and that angle. If you traced that side, it's talking about that angle, okay? So that's how I have that in the back of my mind, and I never forget it. All right, now let's actually practice this. Go to this slide. If two forces, F1 and F2, or vectors, act on an object, the combined effect is the sum or resultant. This is a vocab word right here. The combined effect or sum is called the resultant. It's a very weird word, but it means the vector that would shoot straight out of the middle, which is taking into consideration the two force vectors and summing them together. You know, like our powers combined. What is that movie? Power Rangers. The TV show. You had to be there. It was great in the 90s. Yeah. all the boys had a crush on the pink Power Ranger and all the girls had a crush on the red one. Okay, so two forces act on an object, which means the resultant can be found by finding the sum. This is just a visual to give you an idea. Now, this is the actual example. Here's what it would look like in a word problem. Forces of 15 newtons and 25 newtons act on an object at right angles to each other. This is really important that you pick up on this right here. They are telling you, instead of a parallelogram, we have a right angle, which means we're dealing with a rectangle. Okay? So they're saying you've got two forces. They act on an object at a right angle to each other. Find their sum or resultant. There's that vocab word. Find the sum, which is also called the resultant, giving the magnitude of the resultant and the angle that it makes with the larger force. Now, when you first read this, I know your first thought is, I'm going to walk you through how to solve it, and then I'm going to ask you to tell me if it's actually not that bad. Because I'll be honest, when I see these, I start to freak out because I can't stand, I'm not a science person, but I'm a math person, and the math behind this is very easy. Okay, so let's look at it. First, let's draw a picture. We have one force acting with another force to form a right angle, so let's draw that picture. You want to draw your arrows going away from each other, right? If you look at all of our pictures, they all kind of start from a common point and then they go in a direction. So if they form a right angle, that would imply you have one going up and then you have one going to the right. Yeah. And then I'm going to draw that this is a right angle right here. So I've got my two forces. I do want to label them. This is 15 newtons, and then this is 25 newtons. Doesn't matter which one you put where. It says, find the sum or the resultant. Okay, so this right here, let me get my highlighter. Find their sum or resultant. That is telling me, draw that vector that comes out of the middle of the two other vectors. And then now you can see, and you want to be careful when you draw it. Like, you don't want to draw it like this, because the idea is we're going to enclose it as a rectangle or a parallelogram, but this is a rectangle. You don't want to draw it like that. So you want to basically envision drawing the diagonal, in this case, of a rectangle, and then stop. And now I'm going to go back and I'm going to close in with dotted lines to remind myself I am dealing with a rectangle here, right? So what would this be up here? 25, and then this would be 15. Now, let's go back and read what it asked us to find. It said, find their sum or resultant, and then it tells you how to find it. By giving the magnitude of the resultant. This is your clue to find the magnitude of the resultant, which means find the, starts with an L, find the length. And it says of the resultant, so it's going to be of the diagonal. Because the resultant's that one in the middle. Now, don't run and jump to the distance formula. One, we don't have coordinate points here. Remember? The ones we just did, we had coordinate points for the ends. This is easier. This is a lot easier. We have the actual length of all the edges. What's that thing from geometry that could come in here? If I'm trying to find the length of this, what shape do you see? Yeah. So, you know how this was a right angle right here? and we said that it mirrors the rest of the image, so this over here is also a right angle. So what shape do you see right here in the lower half? A right triangle. Y'all see the right triangle? So if we have a right triangle right here, and we know two sides, we're missing the third side, we can use the Pythagorean theorem here instead of the distance formula. You can't use the distance formula, we don't know x and y's. So you got a squared plus b squared equals c squared. The part that I don't know is which letter. C. Yeah, it's opposite of this right angle right here. I don't want to draw another arrow because then we've got too many arrows in there. But that is the hypotenuse. Doesn't matter how you plug in the legs. The legs always form the right angle. And they are interchangeable because they're just getting squared and then added together. And we are going to round to the nearest tenth. So you would type this in the calculator. Then you would undo that by what? Square rooting. Let's go to the nearest tenth plus you. Did you get 29.1? So the magnitude, bless you, the magnitude of the resultant, I'm just being thorough here, equals 29.1. Lots of fancy terminology there just to simply say what's the length of the hypotenuse of the right triangle in the picture. You will not see that question. You will see find the magnitude of the resultant when two forces act on each other at a right angle, yada, 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 yada. So the hardest part is just being able to read it and say to yourself, okay, I'm just drawing a right angle, I'm drawing the arrow coming out of the middle, which means I have a rectangle now, and then, oh, they want the length of the diagonal, I can use Pythagorean theorem. Now, it also says, and the angle that it makes with the larger force. Now, this is where your picture comes in handy. And it does not matter how you labeled your picture. What matters is, can you find the larger force? So, this means find the angle between the resultant and the larger force. I'm going to change colors to make it stand out. Here's the resultant in blue. My larger force would be the side that has the larger number. So they're talking about right here. I'm going to put a theta. That's what they're asking us to find. Y'all, this is basic geometry. Now, if it bothers you having it in that picture right there, if there's too much stuff, then come over here and just copy the info, that bottom right triangle. You got 25, 15, and then there's theta. So this is a basic geometry problem. Let's remind you how to set it up. Draw an arrow to the hypotenuse so that you can see that we're using what trig function here? Sine, cosine, or tangent. If the hypotenuse is blank, it's always tangent. This is blank. So that tells me I'm using tangent. Remember how you set your trig functions up. It's trig, angle measured, equals fraction bar. The formula for tangent is opposite over adjacent. If you look at your picture, opposite of theta is 15. Adjacent to theta is 25. We want to get theta by itself. Tan would move to the other side by inverse tan. And that would be what you type in the calculator. Second, make sure you're in degrees. Make a note. Calc degrees. 31 degrees. I don't know if I went to the nearest whole number or if it actually rounds to 31.
Do we have to do that?
Which,
Can
yeah, that's the only way to get it. It's just asking for the angle between the resultant and the longer side. And that, if you think about, if you can mute out some of the excessive stuff there, that is just a basic right triangle and you're solving for the missing angle. I already found C right here because of the Pythagorean theorem. I found C. This is C. The length of the... Wait, what do you mean?
Why did we find C instead of the equation?
Those are two totally different problems. This was give the magnitude of the resultant. That is a code phrase for give the length of the diagonal. And that involved us having to use the Pythagorean theorem. And then this was give the angle between the resultant and the larger side. Y'all go to the next one. Start it out, draw the picture, then you may want to pull an old formula sheet out. I don't have it on mine, so that's drives me nuts. Well, you're welcome, in the words of Mallory. Okay, so we're going to look at this. Yep, there it is. We got two forces act on an object. The angle between the forces is 47. Ooh, they gave it to us this time. Find the magnitude of the resultant and the angle that it makes with the larger force. This is the exact same type of problem. The difference is we don't have a right angle. We have an angle of 47, which means we now have that parallelogram. So Pythagorean theorem won't work here. Let's draw our picture. I always make my larger force on the bottom. That's the way I always set it up. So we have a force of 410, and then we have a force of 600. Then we are finding the magnitude of the resultant. The resultant is the diagonal. Then I'm going to close in my parallelogram. And then they do tell us, I'm going to change colors again, that the angle between the two forces, so this is kind of hard to really designate, but I'm going to make a really thick arc here and write that that's 47 degrees. They're telling you that that's 47. Find the length of the resultant and the angle that it makes with the larger force. So the length of the resultant, since we no longer have a right triangle, this goes back to the last chapter or the beginning of this chapter where we learned law of sines and cosines. Remember the point of law of sines and cosines was finding missing side lengths or missing angle measures in non-right triangles. Enter the purpose of it here. The goal is we need to know the length of this, and then it says and the angle it makes with the larger force. So and we need to know theta right there. So that's the goal. I always start with finding the side before I jump to the angle part. So I have included on your paper the formula for law of cosines when you're looking for a missing side. You do need to just remember that you do need to remember that law of cosines has this formula right here to help you find a missing side length, but remember that that's a squared. So when you do plug everything in, you're going to come to a really big number. You have to square root it. Okay, so remember, you're not done by just plugging it in. You have to square root it. All right, so let's look at this. What do we have here? Let's label some more stuff. This is 410, so what's this? 410. And then you can label up here. It's not going to come into play. If it bothers you not to label it, you put it there. I also immediately find my other angle in the picture. So if this corner is 47, remember, imagine that as like a puzzle piece sliding to the right, lining up with that. So these have to be supplementary. So let's make a note. Remind yourself that, let's abbreviate, consecutive angles add to equal 180. This is going to come into play right here. So if this small angle is 47, then this angle over here is going to measure what? 33? Right? So I'm going to come in my picture and label that this is 133. Now I did that because my goal is to find the length of this resultant. I'm going to actually take this question mark off and I'm going to put an X. So I have a letter. Or you can call it A. It doesn't matter. If it bothers you to call it X, then call it A. But look at the formula for finding a missing side. The side you're trying to find is the other two sides flanking it, right? The other two sides squared, added together, minus those same two sides multiplied by 2, and then notice that this is cosine A. So you have to know the angle that is opposite of the side you're trying to find. So that's what you've got to remember from law of cosines. So right here, that's why I needed the 133, because it's what's opposite of the resultant. Does that make sense? So now I can plug everything in. So I'm going to make a note that we're using law of cosines. All right, so x squared equals, I'm focusing my attention on just this triangle. Okay? That's where my attention is. So x squared equals the two sides, doesn't matter how they go in, that we know, squared minus 2 times the sides, times cosine, and then the angle that's opposite of the one I'm trying to find. The side I'm trying to find. Once you get it on paper, now you go to your calculator and you type all of that in. And I went ahead and rounded, I believe, to the nearest whole number on this, and then square rooted it. Because the problem doesn't give any information. So when you type the whole thing in, I left the decimal in my calculator. It's huge. It's a massive number. I left it in my calculator, but on my paper, I just wrote the whole part because it's such a massive number. Then you have to square root both sides. So I square rooted the decimal in my calculator, and then I rounded that final the square root part to the nearest whole number, which was 929. So the magnitude equals 929. Now we've got to find the angle between the resultant and the larger force, which is theta in our picture. I personally have trouble sometimes muting out info, especially with formulas when I have to be careful with what I plug in. So I'm going to copy that exact triangle. Well, I'm trying to copy it. I'm going to copy that exact triangle right here and remind myself I'm looking for theta. I know this is 133. What do I know? I know this is 600. I know this is 410. And I now also know that this resultant is 929. So how can I find theta? This should ring a bell. I'm going to even go back to my green highlighter. You have an, what? Remember that? You have an anchor fraction right there. It does require you to use your answer from the previous question, but you have an anchor fraction, which means we're using which one? Law of sines. If you recall law of sines, it's the side over the sine of that angle. So I went ahead and put my anchor fraction into place. Got 929 over sine 133. And then which side is going to be used for theta? 410. So 410 over sine theta. Now this is nothing new. You should know how to do this. We're going to cross multiply this behind it and this behind it. So you got 929 sine theta equals 410 sine 133. We want theta by itself. 929 is going to move by division. And then sine moves how? Inverse. So this divides under here. And then the sine goes away, and you need to type in your calculator second sine to get the inverse. Sine inverse. I went to the nearest 10. Did you get 18.8 degrees? Okay. Now what I want you to do is to go back to the last slide. Go back to the last slide. These are the exact same, oh, I went too far. These are the exact same problems. The difference is this was a right triangle. This was a right triangle, which involved geometry concepts. Pythagorean theorem, basic trig. This was not a right triangle, which involves law of sines, law of cosines. So that's the difference between the two.
Well, law of sines and law of cosines formula again.
Yeah, absolutely. So those two problems are the exact same question, layout, everything. The shape is the difference, which sets the tone for how you solve it. So don't confuse them and think there's two totally different things going on here. They're the same thing. It's just if it's a right triangle, it's Pythagorean theorem, basic trig. If it's not a right triangle, It's law of sines, law of cosines. Okay? Alright, now you're gonna enjoy this. This is a breath of fresh air. Those are the most detailed, like time-consuming problems. Oh. These are the next part is the fewer steps, like so few steps you almost feel like you're doing it wrong. You know that? No, I'm saying I don't have it. This is saying, okay, you have an airplane. They give you the picture, thank goodness, because I don't know what direction bearing. We've got the speed of the airplane, we've got the wind blowing, the ground speed of the airplane, and the directions of its tracking course over the ground. From the text. I don't think that is in your, let me look, in your, where am I going with this? Homework. Because if it's not in the homework, then it's not going to be on the test. No, I don't see it. So, breeze through, go to the next slide. Just go to the next slide. Go to this one. Okay. If you have a highlighter, highlight the word components. This is going to help you to understand where to look in your notes when you go to start the homework. If you look at this picture, this is the reverse direction of what we just did, and this is actually way less work. So what did we just do? What we just covered was, I'm going to give you one vector and then another vector. I'm going to tell you the angle in between them so you know how to draw your picture. And then I need you to find the magnitude of the resultant and then the angle between the resultant and the larger force, or smaller force for that matter. This is the reverse. I'm going to give you the resultant. I need you to tell me what were the components that would come from that resultant, okay? So if you look at this picture right here, make a note that this would be given to you, and you would be finding U and V. So we're going in reverse. You need to know this vocab word to know when to go in reverse, and thankfully the vocab word is very similar to the word reverse itself. You are going to be what's called resolving the vector into its two components. So you need to think of that as reverse concept of what we just did, okay? And it's very, very simple. It's basic trig, thank goodness. Basic trig geometry. Let's come to a practice problem. A vector W has a magnitude of 130 and is inclined 40 degrees with the horizontal. Resolve the vector into horizontal and vertical components. So they're telling you from the get-go, you have a vector whose length is 130 with an incline angle of 40 degrees to its horizontal vector. Resolve, there's the vocab word, resolve the vector into horizontal and vertical components. Now let's draw a picture. It's basic right triangle. We have a vector that they are giving me with a magnitude of 130. They want the horizontal, I'm going to call it H, and the vertical, I'm going to call it V. And they tell me that the resultant, the vector with a magnitude of 130, is inclined 40 degrees with the horizontal. So 40 goes where in my picture? Bottom left, bottom right, top. Where's the 40 need to go? Bottom left. It says it's inclined with the horizontal. And you should know that the bottom right will be a perpendicular, a right angle, because any horizontal line is always perpendicular to any vertical line. So this is a basic right triangle, and we are finding the two missing sides, which involves basic trig 2 times. So let's find H first. If I'm finding H, that means you need to ignore V. You don't want to set it up and have H and V in the same fraction. So imagine covering up V. Look at this triangle. If it helps, label your picture. You got your hypotenuse. You have your angle right there. Opposite would be over here, and adjacent would be right here. Remember that from geometry? So if I'm finding H, that means I'm using the, what? I'm pointing to it. I'm using the adjacent, and then if I have H, I need now to use the side I know. Can't have two variables. I would need adjacent and hypotenuse. What trig function uses the adjacent and hypotenuse? Cosine. So set it up. Cosine, angle measure, equals fraction bar, adjacent over hypotenuse. We're going to cross multiply the denominator over here to the front. I call it an elbow arrow. Then you go to your calculator and you type it in. I went to the nearest whole number. So type that in, tell me what you get. $100? Yeah, I went to the nearest whole number because they don't say what to do. All right, now we're going to find V. What trig function will I use for V? Look at your labels. You got opposite, and then you need hypotenuse, sine, angle measure, equals fraction bar, opposite over hypotenuse. Cross multiply it to the front. Go to your calculator. So if you label them, bless you, H and V, then you don't have to go back at the end and say, by the way, the 100 is the horizontal and the 84 is the vertical. My math lab will have boxes for you to fill in. I got you. Right here. They'll have boxes for you to fill in that say horizontal or vertical. All right. So while that problem sounds really uncomfortable when you're reading it, what do you think? It's just drawing the picture. You got to draw the picture because then you're going to see, then you can label your sides and you can see which trig function you're using to solve. All right, let's do this one. A vector W has a magnitude 100 and points southeast. Resolve the vector into easterly and southerly components. That would be a fancy way of saying finding the horizontal and the vertical, okay? You don't necessarily have to know your cardinal directions here to get it right, because you should know we're drawing a right triangle. You just need to put the vector W having a 100 magnitude on the diagonal. But let's help you out with cardinal directions. Remember, north, south, and then if no one's ever told you this, because I know somebody says never eat soggy waffles or something. I never learned that. I just know north, and I know south, and I also know it spells we. That's how I knew it spelled we, not you. All right, so we have a vector W, has a magnitude of 100, and it is running southeast. If you really want to try to draw this according to what it's saying, you can see that we're going to go down and to the right, drawing our vector. Then it says resolve the vector, which is that fancy way of saying you're finding the two components that would make that vector of 100 right there. And then they tell you what direction to find them. They want easterly and southerly. So easterly, oh, I don't like that line. You have an eastern and a southern. And of course they come together at what? The right angle. And I'm actually going to label, instead of horizontal and vertical, what do you think I'm going to label with? E and S. So this went to the right, this went south. Now in this particular problem, what do you notice is missing from our information? They did not give us an angle. Let's make a note. Since no theta is given, it's assumed S equals E. Since they didn't give us a theta, it's assumed that S equals E, which according to my picture is kind of hard to believe because my E looks a little longer. But if S equals E, then what type of triangle do you actually have? You actually have an isosceles. So if this bothers you over here, you could just copy a picture of an isosceles triangle right here and make a note that those are equal. So if I find one side, I found the other, right? Do I want two different variables necessarily here? What would be a wise thing to do over here? Just go with one variable, right? It can be both S or they can be both E, or if that bothers you, you could just say, hey, they're both X, because they're equal. Now we have a basic right triangle. Don't you dare try to use law of sines or cosines when it's not necessary. We have a basic right triangle. We're talking about the sides of the triangle. We now have only one variable, so what can we use? Old Pythagoras. Pythagoras, or the what?
All right, I got you. Hold on a second. It's the Pythagorean theorem.
You might be wondering how we can use the Pythagorean theorem here. It's because the two sides are equal. Because the two sides are equal, when we plug this in, we only have the one variable, which means everything's okay. So we've got x squared plus x squared equals 100 squared. Don't overthink this. That is 2x squared. 100 squared is 10,000. What do I need to do with the 2? Divide it to the right. Brain fart, 5,000. Square root that. I went to the nearest whole number. Because it was ugly. So what is the component for the southern vector? 71. What's the component for the eastern vector? 71. Go right here to this one. This one is short and sweet. Luggage wagons being pulled with vector force V has a magnitude of 780 pounds at an angle of elevation of 60 degrees. That picture will be drawn for you. You would never have to come up with that picture on your own. So here's what we've got going on here. This is pulling that luggage cart. You've got, this is a 60-degree angle. They're telling you that the magnitude of that vector is 780. So I went and I copied the triangle I see right here. I copied it here. And then I labeled it, this is 780, this is 60. It says, resolve the vector into horizontal and vertical components. So this is the exact same problem, but actually easier because of where the variable falls. So if I'm solving for h, what trig function would I use? Cosine. So cosine 60 equals adjacent over hypotenuse. Y'all can pack up. I'm going to finish writing this. And then I would use